Hello, welcome back to PLSQL tutorial. In this tutorial, we're going to discuss about lexical units and variables. And then, so what is a lexical units? So if you see a PLSQL program, this PLSQL program is written in lines of text. The example of a PLSQL program is like this. So it's written in lines of text, and then each of them is we have say character, and then we have all this special symbols and all this thing, right? So basically, what I'm saying is that the PLSQL program will contain these kind of characters. It can be a lowercase letter from A to G, a numerals from 0 to 9, special symbol, tabs, and all this thing. And then the other thing is that this bunch of characters together call a lexical unit. So this is called a lexical unit. So these lexical units are of 4 different types. They can be a delimiter, they can be identifier, they can be a literal, they can be comments, depends on what is there. So for example, a delimiter is something a special symbol, like a plus sign, ampersand, quotes, dot, and hash. So I'm just showing you here only 5 delimiters. This is I have taken from Oracle PLSQL documentation. You go to the documentation, you will see there are 25 plus delimiters available today on Oracle 11g. They have all their meaning for that. Okay, or some people call this an operator. Okay. Next one is identifier. The identifiers are variables, reserved words, cursor or cursor variable. So these identifiers are allowed. You cannot really do something by randomly. Okay, so if you add 5 random characters, it's not going to be an identifier. There is a rule to make an identifier. So those rules are here. I don't want to get too bored in looking at the rules. Let's take some example. Say for example, X. This is a valid identifier. Whereas dots, ampersand, dashes is not a valid identifier because we do not allow any special characters like hyphen, slash, space, or ampersand. Okay, and debit hyphen amount is not is invalid identifier because this is not obeying this rule. Okay, so basically these are the couple of rules that we that say to make an identifier. Okay, and then literals is something explicit numeric character or string. Here is a numeric literal. Hello world is a string literal. G is a character literals. True and false are Boolean literals. And then we have comments, which is a double, two hyphens. And also we have C style commentings that we have seen before. Okay. So let's take an example. In this example, let's try to see so this is basically an identifier. This is a keyword, a reserved word. And this is identifier, which is a variable. This is a reserved word. This is a delimiter. This is a numerical literal. And then all these things are identifiers. Again, this is a character literals. This is an operator or delimiter, and so on. Here's your comments and all this thing. So essentially what I'm saying is that your PLSQL program will contain the character that is defined here in this one, and it will contain the words that will be of this lexical units. Okay, so with all these things, I think the most important lexical units are variables. And in this next couple of minutes, we are going to discuss about variables, how to use them, and then we'll show you a couple of examples of how I use variables. Okay, so with the reason I use variables, I want to store temporary data. Let's say, for example, I want to say that I add 5 plus 10. So if I add 5 plus 10, this operator, what is the resultant value? I need to store somewhere. Okay, otherwise it's not of any use. So in that case, I define a variable as a result, and this result I define this variable to be a number type. That means 5 plus 10, whatever the resulting values comes, it's going to put here. Okay, then once I store this result, I can manipulate this result. I can use this result later on in my program. Then another thing is that if I have defined a variable a is equal to 5, sometime down the line, I can also use the same variable a is equal to 10. I can reuse the variable for different things. And another thing is that if I start writing the variables and all those things, my program is more easy to read. If the program is more easy to read, then it is more easy to maintain. There are different types of variables. there are two types of variables on the broad, like the PL-SQL variables and non-PL-SQL variable. Okay, and in case of PL-SQL variable, we can divide into four types. The first one is scalar. The scalar variable is something where we store one data at a time. Okay, so if this is a scalar variable, that means you tell me, like, what kind of data is stored there. It's a number, or it's a varchar, or it's a date, or it's a integer, and so on. It's a composite data type. When I'm telling, I can store multiple things in one data. Like, composite data type is something like a structure in C, or like a in this, what I can do is, in the composite data type, I define what kind of individual elements that I'm going to store. If the individual elements here in this composite data type A, I'm going to store A1 and S1, where A1 is a number and S1 is a varchar. Then the A is going to look like something like this. So this is 5, and this is something called XYZ. Okay, so this is what I can do. Like, if I declare this A as a composite data type. Okay, then the reference data type is something that we do not know in the compile time. What kind of variable is that? We'll attach that variable to a database or a table column type, so that at the runtime we'll get what is the column type, and then we can use whatever the column type, that is the type of this variable. We'll give an don't worry about if it is getting over the head right now, because we are going to show you some examples and where things will be more, going to be clear. Large object. So this is where, like, we can store unstructured data, and Oracle 11, Oracle 9i onwards, there's a lot of support for manipulating this unstructured data. Like, you want to store an image, you want to store binary files and all those things. Those things will be done by large object. Then another thing is that sometimes you call an SQL or PL/SQL from another program, let's say C or Java, or even Perl, or whatever language that you can do. So this language is called host language. Okay, so from host language, I can define some variable, and I can pass that variable to the PL/SQL layer. Okay, and that is what is called bind variable or host variable. Okay, so we're going to show you a demo how to do bind variable. So without further delay, so let's take a look at some of the demos. So this is my first demo. This is where I'm saying that wages is a number, and hours underscore work is a number, and then I have assigned that, like, I declare, and also at the same time I assign. So this is how you do. You declare and assign. Then there are some other number data type. There's a country, which is varchar, and then it's a counter, which is a number, and then I define a Boolean variable, and also I define another variable called C underscore tax. This is called constant. Okay, we'll see, like, what that it is. So let's take a really stab at it on my. Okay, so this is a variable, right? So that means what I'm saying wages. I basically, by line number 2, when this line number 2 get executed in the memory, I will have a space called wages, where by default nothing is there, because I just defined that one. Then also I have defined another thing called hours underscore worked. Hours underscore worked, I do not have. I have a default value that is 40, because line number 3. So whenever I'm going to execute this what is going to happen, and so on. And I don't want to do this bonus and hourly salary, because there's some number and there's a country. And in this country, I can only store a character, no numbers allowed, because this country is varchar. And this is 128, up to 128 character. Then there is another variable called done, and this is a Boolean variable. That means it can contain either true or false. And another interesting thing called C underscore tax. What I say here, this variable is constant. That means the value of this variable can never be changed during the program execution. So whenever you do that, C underscore tax, and then you initialize this to 6.78, that means during the execution, you never can change the value of C underscore tax. since I have changed the C underscore tags in line number 18, essentially for this, I will get an error. Okay, so let's see like how this program works. And then at line number 9, after this program executed, I will have boxes like this. In some boxes, they have initialized, that means they have a value. In some boxes, it's null, means it's nothing is there. Okay, so I have one box called counter, and when it's created, that's created at the line number 7. Okay, and the value is 0. And then at line number 11, this counter value is incremented by counter plus 1. So therefore, the old value is gone, and we have a new value that is 1. Okay, then I calculated wages based on this mathematical equation, and then so I have this variable wages that must have created in the line number 2, that has been whatever the value that we got out of this thing is there. Let's say that is 950. Okay. Then country is equal to France by line number 13. So country was null, as now it became France. Okay. Then what I'm going to do in line number 14 is I am trying to assign the value of this expression. So counter is equal to 1. So can you see like counter became 1 in line number 11. And in line number 14, I'm trying to compare what is the value of counter to 1. If the value of counter is equal to 1, then this counter is equal to 1 will return me true, which is indeed, because counter is equal to 1, we made it in line number 11. So therefore, the counter is equal to 1, this statement will return me a binary value which is called true. And since done is a Boolean variable, so therefore I store here true. So now if done, that means if true, because done is value is true, then you print this DBMS output put line and you print the wages. Okay, so this is how this program is going to run. And this program is, if I execute this program, and just for time being, I'm going to comment this thing just to, okay. So if I run this program, it's okay. So I give the password. Okay, so anonymous block completed. And then if I go to DBMS output, I just want to enable DBMS output. Let me rerun again. And wages is 1050. Okay, so all this is computed and wages equal 1050. And as I told you, if I try to modify the value of C underscore tax, which is a constant, it should give me an error. Okay, so essentially it is giving me an error. It's saying that expression C tax cannot be used in assignment target. Okay, so that's the reason why it's giving me an error. So I hope this scalar variables has got clear right now. So let's move to the next variable. It's called reference variable. In case of reference variable, we do something here. Let's say I declare a variable wages. So if you imagine the previous case in the scalar variable, I defined wages as number. Let's go back. So here I defined wages as number, right? But in this case, I'm not saying wages is a number or char or date or whatever. What I'm essentially saying it that wages is something similar to whatever the employee table we have, and employee table has a salary column, and whatever the salary column type, if salary column is a number, then wages will be a number. Okay, so basically what I refer wages to employee.sal type. Okay, so this is how you define. This is a new kind of definition. So here wages, I'm not saying it at the declaration time is what kind of variable. Basically, whenever it's going to run, that time it is first thing is going to do whenever you see line number 2, it goes to the database and try to find out what this sal here. This is an employee table. Okay, so what this sal is, and looks like this sal is a number. So therefore, wages is equal to number. Therefore, if I at line number 6, if I assign 50, it's going to work. Okay, instead of 50, if I assign wages is king, then it's going to fail, because wages is going to store a number variable. Why is going to store a number variable? Because employee table salary column is also a number variable. Because we tell to the compiler that you do wages whatever the employee.sal is. So therefore, whenever we're going to add to whenever if we assign king, then it's going to fail. Similarly, name, is I'm saying that whatever the employee table's ename column is, so employee table's ename column is a character. So therefore, I can assign to character. Okay. So basically, what we are doing, the difference between the scalar thing that we saw to this reference thing is that we do not explicitly say at the definition time what kind of variable it's going to be. It's going to be determined at the runtime by the PL/SQL compiler. So that is why this is called reference variable. Okay. The next one is composite data type variable. Okay. So basically, let's go on and check something here in our uh, whiteboard. So the composite data type, basically what I did by line number 2 and this thing, right? So what I define a new data type. And what is the name of the data type? The name of data type is REC. And what does it contain? It contains two things, a number and a varchar. Okay. So this is the definition of the data type. And then this is where I say I declare a variable called v_rec of that data type. This is something equivalent to wages number. Okay. In wages number, I know that number is a predefined data type by Oracle. Okay. And that can only contain a number. But here, v_rec is our user defined data type. First thing we define what is the data type, and then we are saying that now define a variable of that data type. Okay. So number is always going to contain a number. But this kind of thing, this kind of data type, we can define on our own use. If we need two numbers, we can do a number, b number. In case if we need 100 such elements inside that record, then we can define a, b, c up to 100. That's not a problem. So basically, this gives us flexibility to what kind of data type we can use based on our requirement. That is called composite data type. The reason behind composite, that means this data, this variable can contain a number, a varchar, a date, or a combination of all of them. Okay. So in this case, whenever I do this v_rec, so that means v_rec is going to look like this. So v_rec is pointing to this, this variable, and this variable in turns has two elements. One is a, another is b. And a can contain a number, b can contain a varchar. So how do I access this thing? We'll access v_rec dot a, then assign to 5, and then v_rec dot b we can assign to king. And if I ask you what is v_rec dot c, the answer is this is going to give a compilation error because I do not have any element called c. Okay, I don't have any element called c, so therefore it's going to give me an error. Okay, so that means v_rec dot c is nothing. Okay, and so this is how you are going to declare your composite. You'll work with your composite data type. Okay, so here's another thing is line number 8 that we can take a look. That line number 8 tells that there is a record called emp_rec. So emp_rec is of employee percentage row type. That means whatever the employee row, okay, so whatever this row, that my emp_rec will be of that type. Okay, so that means if I want to do that emp_rec, then emp_rec essentially will contain multiple elements. The first element is employee number. Second is employee name. So this is basically we can store a number, we can store a character, and then also a job. Job is a character, and then salary is a number, and so on. Okay. So this is example is a composite data type of reference type. Okay. So we can refer, like, we do not know what employee rec at the time of the definition, but whenever it's going to run that time, whatever the employee table's row type, then it will contain the complete thing. Okay, so that is what is a composite data type, and then that's how you write. The last one but not least is called the host data type. So that means let's take some example, and then with example we can deal these things better. So I'm going to open my Oracle SQL Plus, so that basically I just want to show you for another environment. So I connect with, okay. So while the connection is going on, let's try to discuss something here on this thing. So basically what I'm doing is that, like, I have, this is called my host environment. So from here, I'm executing a PLSQL code. That PLSQL code will go and executed in the Oracle DB. This host environment can be a C program, can be SQL, or can be a Perl, or can be a Java program, or whatever. Okay. So what I'm doing is right now I'm going to define, it's going to show here. So I define a variable, say g underscore sal, and then I define that variable as a number. Okay, that's it. And then instead of declaring a PLSQL block and all those things, what I'm going to do, I'm just going to run this PLSQL unit. Okay, I don't define anything. But look at this. So how do I write this thing on a scalar variable? Then how would I have done? So I could have done declare g underscore sal number. Then I do begin, select sal into g underscore sal from emp, where emp number is equal to, say, 7369. All right. So if I do that, so there's you can see a difference, right? So here this is a PLSQL scalar variable, but here it's not a variable; it's just a host variable. It is not a part of any PLSQL block. Then inside that PLSQL block, instead of just doing g underscore sal, looks like I'm doing colon g underscore sal. Yes, that's the key. The key point here is that you define a host variable, and inside the PLSQL block, you can access to that host variable by using colon. Okay, so if I run this piece of program, so like let's say I have already done this thing, so I'm going to copy and paste. So if I Control C and then I run, okay, so our PLSQL program successfully completed. So what it does is for employee number 7369, whatever the salary, that salary is come and then put into the variable called g underscore sal. So let's see, like, if I want to take a look, like, this is my table. This is my employee table, and then this is my data for 7369. Okay, actually this is going to give null because there is no employee which is 7369. So therefore this select basically returns you null. Okay, so that if I do print g underscore sal, it should give me null. Oh, it's giving me 800. Okay, let's see, like 7369. 7369. Okay, 7369 is Smith. Okay, so that's the reason. So Smith is a clerk and his salary is 800. So this 800 is coming and then put into the salary called g underscore sal. So therefore, whenever I'm print g underscore sal, I'm getting this value. Remember, this is a host variable. This variable doesn't have anything to do with the PLSQL end. The PLSQL basically returning something and then putting into g underscore sal. So this all about your variable concepts. And then what I want to do, just try to explore certain programs so that you can be better equipped with defining a variable and all this thing. Thanks a lot. And then take special attention whenever you are writing, defining this variable and all those things. If you make some mistake like this, it's going to give you some weird error in PLSQL. It's very difficult to figure out. So just make sure that you are defining the variables properly. Thank you.